Welcome to the next lecture of our course, and in this lecture we'll be talking about creating a non-blocking code using asynchronous programming. In our last lecture, while we were talking about the blocking code using the web client that we wrote, it was blocking both the responses and it was printing both the responses same time, because even though the first response is going to be faster, the second response is going to take so much of time and it is going to print both of them together. It's not going to print the first response if it is completed, because that is not how the synchronous code actually works. So that was the problem that we have got. And now we are going to be creating a non-blocking HTTP call using an inbuilt C# method. So we are going to use an HttpClient method of C# library. As you can see, this HttpClient actually has got an async method as getAsync operation, and it is going to use an await keyword. So in order to understand the code even further, this is how it's going to look like. As you can see, this particular method, the fetchDataAsync method, has got an async of task of string written over here, which means it is going to be an async method. And because this is going to be an async method, you should see some await keywords within this particular method. And as you can see, we have got an await over here. We also have got an await over here. But before we get too much detail into it, let's go one line and another so that you can understand things much easier. So the first line of this particular code, as you can see, it says private static async task of string fetch data async method. So in C# world, the convention is you write an async method with an async as the suffix. That's the reason why this is like fetch data async. Whereas in our previous code, we just wrote like fetch data because it was an synchronous code. And you can see that the return type is an async of task string, which means it is going to return as a string value out from this particular method. But because this is going to be an async method, it should be an async keyword written there. And also this particular method may be returning as an task of string, not just the string, because this read as string async method, as you can see over here, is going to be returning you a task of string. That's the reason why this is a task of string. So this is basically a return type. And we also have an async keyword here because this is an asynchronous method. And the second line is quite straightforward. We're just calling an HTTP client, and we're also performing a get operation, pretty much like how we did for web client. But just that this method, as you can see, is using an await keyword because it is going to wait for the get async method to complete the operation. So we are essentially telling over here that this get async method should perform a get operation asynchronously, but still we have to wait for the asynchronous operation to complete. So this is just going to keep waiting for this operation to complete, and once it is complete, it is going to give a response for us over here. But while this is awaiting, it is not going to block the main thread. What it really means about that is that the main thread which is running to perform the operation other than the fetch data method may be now freed up, and it can perform some other operation for us in parallel. That is the major power of this asynchronous programming. It's not going to hold or keep blocking the whole entire code for us. And now you can also see that it is going to give us a response to ensure the status code, and it's going to return as an await of this particular read string async. And again, this is an await keyword, and the read as string async is going to perform a reading of string from this particular response for us over here. So this is what is this particular asynchronous program is going to look like. I know for the first time while you see this particular code looks very confusing if you're going to be coming all the way from the synchronous coding background. Asynchronous code is a bit of a confusion, but once you start using it, you will know it is so easy. It's all you have to do is you need to use the async or async keyword and await keyword. And once this method is fully written, we are then going to see how the calling code is going to look like. You can see that the caller code now will be without blocking. So what I really mean about that is that even if you call these two lines of code over here, the first response, as you can see over here, is going to be without blocking the main thread. So because the main thread is now available to perform the other operation, and you can see that it is going to be keep working with the second operation to bring you both the result. And I will quickly show you a demo of how this particular code is going to look like so that you can be clear of what I really mean about them. So now I'm going to go and add a directory over here, and I'm going to call this as async demo, and I'm going to create a new class file, and I'm going to call this as async HTTP client, and this async HTTP client is going to have a method which is going to be something like this. I'm going to say private static async. So this is the keyword that I have to use to make this particular code as async, and I'm going to return a task. I'm not going to make it a string for now. I'm just going to keep it as task, and I'm going to say fetch data async over here, and I'm going to say an URL. So this is the method it is going to perform. And once I write an async, the actual IDE is going to tell me that the async method lacks an await operator and will run synchronously, which means if I don't really write any code as await, it is still going to run this particular method as synchronous fashion. So we have to use the await keyword to make it running asynchronously. So for that, I'm going to say var client is equal to new of the HTTP client, and I'm going to say var response of await client dot get async method. So this is the async method that we are writing, and you can see that this particular get async method is going to return as a task of HTTP response message. So this is also returning as a task over here. I'm going to say response dot ensure success state code, something like this. And finally, I'm going to say return await of response dot content dot read as string async, something like this. So this is going to read things for us over here, and because it is going to be reading and it's going to returning as a task of string, I need to make the return type as task of string as well. So this is what is the fetch data async method going to do for us over here. And now that this is the HTTP client which is going to perform those operations, and now I'm going to write another static method, and I'm going to call this as public static void. I'm going to say demo async HTTP client without blocking, and over here I'm going to say var response 1 is equal to fetch data async over here, and I'm going to pass the URL. So I'm going to pass the same URL. So basically I'm going to copy these two lines of code and I'm going to paste it over here, but instead of fetch data, this is going to be fetch data async. And because this is an async method, as we saw over here, the get async is an async method and it's going to return as a task. We can use the await keyword. Similarly, we can use an await keyword over here, something like this. And once I do that, you see that we are getting an error over here. The reason why this is throwing us an error is because it says that the await expression can only be used in a method or a lambda marked with async modifier, which means this particular method, as you can see over here, should be an async method. So I'm going to make this as async over here, and you see that those two lines are gone. I mean, the exceptions are gone because now it is a legal code for us. So this is how we should write an async await combination of the code while writing an asynchronous method. So now we know that this particular method is an asynchronous code. So now let's try to write the console.writeLine for the response 1 and the response 2, and I'm going to write all requests completed, something like this, which is cool. So everything is now done. I'm going to save the whole code, and let's try to run this code and see how this code is going to work. So I'm going to go back and I'm going to comment this synchronous code, and I'm going to do an async HTTP client dot demo async HTTP client code without blocking. And now if I execute this code, you will notice that it is going to perform the operation, but it is just executed without even executing anything over here. See that? It just executed so quickly. So now let me try to once again execute this. What's even happening? It just executes so quickly and coming out. Guess what? Because as I told you, this is an asynchronous method that we have written over here. And if you're going to be calling this asynchronous method, even though as a static method in this particular class file, you need to use an await keyword. If not, the code is not going to work. So you need to use an await, and then you need to call this particular method. And guess what? There is one more problem that we have made intentionally. Because as you know, in our non-async code, we used to write like a void type over here. Rather, we should use a task type over here. Even though if it doesn't return anything, it should be an task. So async task is very, very important. Only then you can use an await keyword over here. So hope that is now very, very clear. So on an async method, you need to use an async keyword, and then the return type should not be a void, it should be a task. Only then you can perform an await on the other side of the caller. And that's why we have a task over here, and await, we can use it. And similarly, any method which is asynchronous, you can wait for the particular code execution to complete using an await keyword. But what do you mean about waiting is that you are not essentially blocking the main thread. Rather, you are just going to put that in the thread group, and the main thread is still free to perform the rest of the operation. And once the execution is complete on this particular line, it is going to take that particular main thread once again, and it's going to perform the operation and return back once again. So this is how all is going to happen because of the asynchronous programming nature that we have got over here. So now that we have written this whole code, and let's try to execute this code. So you can see that the operation now looks quite similar. So even though I execute this particular line of code, even though I told you that this particular code is running synchronously, while I try to run this code, it's calling the same perform calls method. And now both the lines are printed together as well. Not one response printed first and then the second response is being printed. Why is it even happening? Because this is not what we are expecting as well, right? We should be expecting that once the first line is completed, the first line should be printed and then the second line should be printed. Why is it not even happening for us? Well, in order to do that, we actually need to write some more code, which we'll be talking about in our next lecture. But for now, you have already written an asynchronous code and you have already freed the main thread. I can't show you a demo to say that once this particular first response is completed, the main thread is free to use and then the second response is printed, something like that, until I show you a demo with an Windows app or a web app to demonstrate those operations. But at least you have already written an asynchronous code which is going to perform these operations much faster. In our next lecture, we discuss even further about asynchronous programming so that you gain even more insight about it.